So
Okay.
so this week I had two works. One is to lay out the power speed control circuit. So I did that. So firstly I designed the layout of the delay cell. So here is the layout of the delay cell. As you can see, uh, the four MOSFETs are connected and pins. And then this is then I actually connected the TP and the TN part separately first. So this is the TP part of the pulse width control. So this is the schematic and this is the layout. So the layout is quite long, and that's why the details cannot actually be seen. I tried to capture it as
But
close as possible.
did you check your DRC and LBS?
Yes, I mean in DRC, there were some like messages, but I didn't understand them quite well. I mean, there was no major message.
So what message? Is it density?
Mm, yeah, those kind of stuff.
Yeah. Okay.
Okay, and then this is TN. So TN, which looks like this. So here, and before showing the whole pulse width control, so I also designed the layout of the inverter circuit, which looks like this. And finally, this is the pulse width control. So this is the entire pulse width control circuit. As you can see, I have made two symbols, for one for TP and one for TN. So the two layouts that I just made will be used, and I will also need an AND gate and an AND gate and a NOT gate, inverter gate. And this is the final layout that I got. So I used like different metals and stuff. And yeah, that's the first job. Thank you so much.
But
And
did you check your LBS for final layout? Is this correct?
no, I did not take the LVS for the final one.
You check LBS for smaller block, but your final block
No,
you have
final
not
one I
checked
did
yet.
not. No, I did not check yet.
Okay, do it next week.
Okay, I can actually do it now. Okay,
Yeah, let's try
and
to finish. Actually, we stuck in here quite a long time. This is
yeah,
the
I actually could
easiest,
not.
yeah,
Yeah, I actually
easiest
could
block.
not join the meeting. Yeah,
Yeah,
I will try to like do it fast from now on. I mean, I could not join the meeting last week. I was quite like sick.
okay.
So
You
let me show my other work, which was to simulate the. Wait a minute. Which was to simulate the full symbol with the power. This one, the speed at control. So the changes that here, because of this, the efficiency values are quite low, as you can see, especially when L is equal to 820. The efficiency value is quite low because the period control value is quite high. I could not do this like to finish this because for L equal to 820, it takes really long time for one single simulation, over 1 hour. So ultimately, I could up to N equal to 12.
so did you check what I have said this
Oh,
afternoon?
the current, okay, I will take that. Wait, let me check that right now. Let's go to the desktop share. Yeah.
Let's check inductor current.
Oh, the current is not selected. Inductor current. What was the impression for the inductor current? IPZT, right? Or IL?
IL. Why?
IL, okay.
Why
Here it
you
doesn't
did not
show
save
IL.
it? can you select save?
Oh, I see. Okay.
Let's plot it. Let's try to plot again. No,
Oh, it didn't.
I
It
think
doesn't
you
work.
can check
I have
T,
to send
TN,
it.
and TP. You don't need to check
Yeah,
current.
yeah.
T and
Yeah, I
TP
can check.
will
Yeah,
follow your
TNTP are
current.
all right. Yeah, TNTP are all right. I mean, if I check TNTP, if I go here,
So you can
here N is 12. So, right? Yeah, N is 12. So
No,
TP should,
that
TN should be 693. As
no, I mean you should check your space between two TP, so you miss out.
oh, I see. Oh, okay.
You check the distance between two TP and two TN.
Like here, like the distance between these two spikes.
Yes, two spy and how much?
Ah, this one.
So
18.
you can see it will take 3 clock cycle if you compare to enable signal the clock. So it will squeeze after 3 cycle of clock, right? You can see after 3 cycle it will start.
Yeah, so this
harvest.
cycle starts and then after 3 cycles it's okay.
So you can check with the different.
Okay, let's now check with 8. Yeah. Let's
Yeah.
just do this
Yeah.
and maybe this is this 0 maybe. Yeah. In that case it's n equal to 4. That's 26.
So let's run and
With 820, like 20, like L equal to 820, it takes a lot of time to run as well.
yeah, let's run for 1 millisecond, about 2 or 10 millisecond, and stop.
Okay. Around 5 milliseconds should be enough. I mean, it takes like 2 milliseconds to be stable.
Yeah, okay. So turn off, stop, and check.
Okay.
Do you see it? Yes, you can see between two cycle here. No, in the right, in the left. Yeah, it becomes stable here. So it takes maybe 20 cycle to be switching, right?
Oh yes, it's a
That's
long distance.
That's why it runs very fast and consume less power control.
Yeah. I mean, it's 20 versus 3, so okay.
Right? Understand it?
Yeah.
Okay. That's all.
Thank you so much.
Yeah,
that's all of my side.
Hi, can you share your screen?
Okay. Do you see my screen?
Yes.
Yeah. The first one, my presentation, I have two parts. The first one is the test efficiency for a phone system, and the two is the layout for a phone bit control. This is a phone system for symbol. And then I check efficiency and I figure out the problem came from the point that I measure the current. So after I change it, it's run okay. Yeah, because it take me a lot of time, so I have just test about six case to test, and then I will test more. But I think it's run okay.
But
And another one is
did you calculate the control circuit power consumption of control circuit?
yeah, I have checked this.
Why your
And
efficiency is quite high? You did not.
no, in this case, for more quickly, I have use external power to to a switch.
So you should. So power in it should be P in here plus the power from external supply, right?
Yeah.
You should calculate external power supply and plus P in. That is your total input power.
Yeah. I have tested, but for a short time, so I use external
Yeah.
voltage. Yeah. For quickly.
Yes.
Okay.
Okay.
So about the layout, I have delay. The first one is the delay block. I use the target in the, for example, above either VCC and the bottom is the gate, either GND, and the left is the in and the right is the output, and then it's the not
Nice,
block.
right? I think you
Sorry.
spent a lot of time in here. It look nice.
Yeah. A lot of time.
Yeah.
Yeah, it looks nice.
And another one is not block. I also use the same way like this. And NA to DL block and AN to DL block, and the final is a master block. And I combine everything to create the full width control block. But the problem I have is that my cadence is the correct version, so I do not have the DIC test
So
to
let's
check.
do it next week when you come to KAIST.
Yeah. This is my full layout for full width control.
Yeah.
Yeah.
Okay. That's all.
Yeah. That's all.
So next week you will have fly, so we will cancel next week meeting, right?
Yeah.
So let's do next meeting at
By the way, like home,
yes.
since I like need to like take a little bit more time, like in order to like learn stuff. So like if you like give the like next week stop, I mean meeting after the next week, the 2 weeks later we'll have a meeting, right?
But so next meeting should be September 1st.
Yeah. I mean 2 weeks later, right?
Yes.
So like we will have a task to do at that time, right?
Sorry.
Like we will have a task at that week, right?
What do you mean?
Task. We will have a homework.
Yeah. In 2 weeks, you
So-
should lay out the remaining block. We have so many block left, right?
Okay, so
Yeah.
like okay, so
Yeah.
we will have to like lay out the rest of the block within these 2 weeks.
Wait, I will show you what you have to do now. Let me share my screen. So do you
Yeah, I
see my
see.
screen?
Yeah, I see.
So you still have so you almost done with this, right? Right, power control.
Yeah. This is done.
So next, you should lay out level shifter, right? You have level shifter.
Oh yes, that one.
Level shifter, I think will be fast.
Comparator?
After that, let lay out Yes.
By the way, like, what's the layout of the registers?
What?
Layout of the registers.
Register?
Mm-hmm.
Register is, I think it's easy. I will tell you next week when Thai come here, but you can lay out yourselves this level shifter, and then comparator is the most difficult things in here. It takes a lot of time.
Okay.
So let's try to lay out level shifter first, and then start layout comparator. So in the last meeting, I send you your this layout lecture notes.
Yeah, I did not understand a thing from this lecture notes.
So you should read this.
Yeah, I tried.
Wait. Here, actually, comparator actually is the amplifier, and it will have circuit similar like this, right?
Mm-hmm.
So you can see in your comparison. So we will have, hello.
Yeah, hello.
So in comparator,
Thank you so
you also have two brand that symmetric brand, right? Like this
Mm-hmm.
one and this one, M3, M1, M4, M2, they are symmetric. So you have to follow this rule to make the layouts match. So you can read here the symmetric. So follow these rules to lay out your chip, right? In here they have the layout example, so you can follow here to lay out your comparator. Read this carefully. Okay. So maybe in YouTube we'll have some guys for layout. Amplifier. Yeah, you might find in YouTube. Okay. Okay.
Okay.
They will guide you how to lay out your amplifier. Read the lecture and find on the internet to lay out your amplifier. Okay. Okay, you got it?
Okay.
Okay, so we can stop meeting here, right?
Mm.
Okay, bye.